travel the world and the seven seas. Everybody's looking for something. Some of them want to use you. Some of them want to be used by you. Some of them want to use you. Some of them want to be abused.
All right. Here we are. Week 2. I don't think there's anyone watching live yet, but as they start to flow in, I'm sure we'll get some chat going. All right, let's get going. Let's get started on this. Give it a couple minutes as we do some review from last week. So if this is your first time watching this, this is week 2 of an 8-week course that I'm calling Game Development Bootcamp. If you're new to the channel, I did have a course that I released about 2 years ago called Game Development Basics, and this is kind of an addition to that, adds on. We teach them new things. It's also a refresher to the old course. In game dev and software development, things get stale after about 2 years, so the hope is that this is an improvement to what we had already made, and it's also some updates. So if you again, if this is your first time, this is kind of an overview of what we're going to be doing in these 8 weeks. So last week we went over some very basics. We installed Unreal Engine. We got started on our first project that's called Fire Escape, and we're gonna spend this week kind of building upon that and completing our game loop. Weeks 3 and 4, we're gonna make a game called Alien Defense. We're gonna learn about object-oriented programming and data structures and data tables. Week 5, we'll learn about source control, and we'll also get started on our third project, which I'm calling Action RPG, kind of like a Witcher or Fable type game. And then we're gonna start building upon that in weeks 7 and 8. We're gonna learn a little bit about C++ and how you can use C++ and blueprints together, which unleashes the power of Unreal Engine, really. And then in week 8, we're actually gonna go back and we're gonna put some extra work into each of our projects, and we'll go over how to launch your game. Here's the schedule of when each of these classes is happening. So if you missed the last week, the recording is available on my YouTube channel. This is week 2, so that's today, the 15th, right? Yep, I checked, it is. Week 3 will be next Friday, then we're gonna skip a week. I have some personal stuff. Week 4, we'll do the weekend of 4th of July. And then you see the rest. So if you're interested in coming back and doing this week after week, I am trying to do it in a way that you could follow along and it could be interactive. I try my best to keep an eye on the comments, and I'll answer questions as they come up, but I'm not the best at that. So if you ask a question, I don't respond right away. Be patient, I'll try to look, because it's kind of hard. I got 3 monitors. It's like, you know, so here's what we're gonna do this week. A lot of this is just general game development stuff. Some of these things are more specific to Unreal Engine. Today we're going to be learning about the game mode class. This is where we're going to start building the rules to our game Fire Escape. We're going to learn about arrays and loops, timers, widgets, and UI. We're going to learn about a thing called an interface and another thing called an event dispatcher. These are used to get different parts of your game communicating to each other, create some more robust code. Then we'll do how do we pass input into Unreal Engine. We'll use the new enhanced input system for this. So we'll go over some of the basics of that. We're going to create an interact system. So we're going to allow the player to interact with things in the world. We're going to use this to make a simple door switch to unlock a door. Pretty easy stuff. And then we'll set up a main menu. We'll set up some level transitions. And then we're going to, whatever time we have left, hopefully we don't run out of time. If we have any time left, we'll do some finishing touches on our game Fire Escape. If you missed last week, I'll just go over kind of what we're going to be covering, like big picture wise. So we're going to talk about game development basics throughout this course. We're going to teach some basic programming principles using Unreal Engine blueprints and the C++. We're going to teach how they work together. We're going to teach some common design patterns used in game development. We're going to apply our skills across multiple prototype games. So as you saw, we're going to make 3 different prototypes. And then we're going to prepare you to start your own personal project or to collaborate with teams. What we're not going to do, we're not going to teach every aspect of Unreal Engine. This is a basics course. We're going to try to teach a little bit about a lot of things. The goal is that you kind of have a baseline of knowledge that you can then build upon and continue learning whatever part you want of Unreal Engine. We're not going to teach anything super advanced. So if you're intimidated by coding, this should be a very beginner level course. You should be able to handle everything even without any knowledge of programming. But if you want to continue your development, I will give some resources at the end of the course where you can continue to learn and grow those skills. And we're not going to create polished games. We're going to create 3 prototypes that you can build into your own projects or build into your portfolio. But these are not going to be complete games by any matter. It's just kind of like the foundation or the building block for you to start with. So I think, yeah, we'll do this last one too. I might delete this after this week. So if you're following along on the recordings or if you're following along on the live stream, try to keep up with me as much as possible. If you get stuck or you get a little bit behind, you can ask questions. One of the beauties of having a recording is you can pause it, you can go back. So try to keep pace with where we're at. Each week we're going to cover something. That also means like if you're trying to keep pace with the course, try to do only the things in that week. If you're watching the recordings, don't try to like catch up all in one week. It might be a little bit too much to do in one week, depending on your schedule. You want to give yourself some time to digest the information from each week before moving on. Complete the lessons in order. So this is just a recommendation. There's a lot of stuff here, and if you try to do things out of order, you may miss something. So even if you think you understand things, just watch and follow along as much as you can. A lot of the stuff that we're learning is straight out of the Unreal Engine documentation. So if you get stuck, that's a really good place to start. You can also join the Discord. I added an awesome QR code. Oh my God, it's so hard to do. Look at that, it's right up there. That you could just scan, join the Discord right away. You can talk to me, talk to other developers, talk to other people that are going through the course. There's some really smart people on there, people smarter than me. So it's a great place to get some help. And it's a pretty small community still. So some of the other communities that have like 15,000 people, may be harder to get an answer, maybe hard to like filter out all the noise. Because it's a small community, it's usually a little bit more, personal, and people take the time to help you. Make these projects your own. So we don't want a million carbon copies of the same project that I'm making. It's good for you to put your own spin on things so you don't have to follow exactly as I'm doing. Make sure you understand the principles, make sure you're doing things in the general way I am, but put your own spin on it. And then challenge yourself. So if there is a point where you start to feel stuck, you start to feel like maybe you're not understanding things, it's really important to try to dig deep, try to really gain some understanding, lean on the resources, lean on other people, lean on me, lean on the documentation. And that's really how to be successful in this course. So let's go here, this way. All right, I'm just gonna switch up real quick. We're going to go into our first lesson of the week. All right. So week 2, if you missed last week, we got started on our fire escape project. This week, we're going to build upon that project even more. So we're in this first lesson, we're going to create a really basic game loop. For this, we're going to explain the purpose of the game mode class, and then we're going to demonstrate setting up a game mode class, and we're going to build some functionality into it, but as we go on, we'll continue to build throughout the week onto this game mode class. So what is the game mode class? If you're new to Unreal Engine, you may have heard of this, you may not have, you may have used it even, but the game mode class is designed to handle gameplay functions. So when the players enter the game and what classes will we use, oftentimes in a single player game, this is used to hold the rules of the game. So you can think of it as like the referee if you were dealing with sports. You could think of it as like a dungeon master if you were playing Dungeons and Dragons. So it's just something that's gonna like make sure that the flow of the game is happening the way it should and that the rules of the game are being followed. It also is handles when the game is paused and what happens when the game is paused. So I like to think of this almost like, you know, just someone making sure that all the pieces are falling into place correctly. And one of the things about the game mode class is it's loaded up when a level is loaded, and as long as you're in that level, you cannot change the level. So it's very common to have different game modes for different levels. We'll talk about this throughout the week and throughout further weeks, but just for now, understand that when you load into a level in Unreal Engine, the game mode for that level is loaded, and then you can't change it. So you want to make sure that you have everything you need when you're loading it up. Get it? Thanks. Thanks, the Nuts Network. I will get it. Just a quick note, we're not going to be doing multiplayer in this course because it's a little bit too advanced for a beginner course, but just a note that if you're making a multiplayer game, the game mode only exists on the server and it's not replicated to the client's replicated, meaning like there's a copy of it. So for this reason, there's another class called the game state class, which usually serves a similar purpose in multiplayer games. You really should be using like both of them to handle different things because you don't necessarily want players to be able to handle like control server side code. So you use the game mode to handle server side things, game state to handle client side things. So again, multiplayer is a little too advanced for a beginner course, but just if you are, just a note. I think it's worth saying if we're learning about the game mode class. So we're going to make a game mode class. So I'm going to open up my project that I already have open because I'm trying to be a better streamer and not be so, I'm just trying to be a little bit more like on top of things, right? I spent some time prepping this morning, hopefully in the hopes that it leads to a more productive stream. Let's change the view also. That way you guys can see a little bit more of what I'm doing. And just because this is where we're starting off, just want to show what we have. So far, we created this game from the first person project. So if you've used the first person template, probably looks pretty similar. We can go and grab this gun and we can shoot it. And up in the top, we're printing the number of ammo bullets that we still have left. So we're down to 76. We can go one of these barrels. It's going to refill our ammunition. And now we have 100 again, and we can do that. So the idea is that these bullets are water. This is like a water gun. We're not going to be killing things. We're going to be putting out fires in this game. And those barrels, oh, we got a bug already. Yeah, we'll fix that later. These barrels are like water barrels that you can use to refill. We also created our first level 1. We'll load that up. And we have these fires. So the gun, we can pick it up and we can shoot it at the fire and we can put out the fires. So that's what we did last week in week 1. If you missed it, you can go back and watch it. If you wanted to follow along, you probably should, but it's not necessarily just if you just want to kind of watch and see what we're doing. So one of the things I want to do is the win condition of this game will be to put out all the fires. So when we talk about a game loop, we usually have like a win condition and a lose condition, or maybe you only have one or the other. If you're going like a high score game, you wouldn't necessarily have a win condition because the game is just go as long as you can without dying. So in that case, you wouldn't necessarily have a win condition. Maybe you'd have like conditions for like when the player gets bonuses or anything like that, but you would only typically in that type of game, like a wave-based shooter, I think of often, like the goal is to just get as far as you can, as many waves as you can. There's no winning. There's really just a losing, and then you keep track of like how far you can get, right? So oftentimes these winning and losing conditions can be, you can program them into the game mode. Now this project template comes with a game mode. We can see it if we go to first person and then blueprints, and then you can see it's a first person game mode. I don't want to use this one. We're going to start from scratch. So I'm going to go to my blueprints folder, and I'm going to right click and I'm going to select blueprint class. And here we can see we have game mode base. So I'll select that one. I'm going to call this one BP. Let's call it like fire escape game mode. All right, that sounds good. The game's called Fire Escape. We're going to be putting out fires. All right, and if I open this up, it looks kind of like the other blueprints that we made from last week. Where did it go? It's tiny. That's weird. Let's dock this. I don't know why they're opening like tiny like that. It looks a lot like the blueprints that we used before. It does have a blueprint, a viewport. I have no idea why you would need a viewport for a game mode, but whatever. We're gonna close that. It has a construction script. Again, we're not necessarily gonna be using these for this course, so we'll close that, and then we just have our event graph. We can see that we have begin play and tick. We don't have an overlap component because this does not by default have an overlap. We would need to add something to it, and I don't know why you would do that for a game mode, but whatever. I'm not trying to tell you how to do your business, Unreal. One of the difference though is if we go to class defaults, on the game mode, we can see that there's all these preset classes that we can put into our game. So for instance, our player is called BP first person character. Let's call this BP player character, just so we can see what's going on here. So we can go to our default pawn class, which again, remember the pawn is a type of actor that we can take control of, and we can set that to BP player character. We can also set some of these other things. So we can set like, as you see here, like game state, we can set the game state. For each game mode can have kind of some base classes built into it. Player controller, we can set up to our first person player controller, all these different things, right? So if you're wondering like how to control what player gets loaded into a level, this is where you would do that. So we're going to go ahead and compile that now that we have our first person character. And then one of the other things I want to do is I want to show how to set that when we open this level, this game mode is going to get loaded. So if we go here to world settings, we can see game mode override. Now we can set this here. We could set it to fire escape game mode. Or otherwise it's going to do, if it says none, this is like an override. So it would override like the project-based game mode. So we're gonna leave it as none because we want fire escape game mode to be the primary game mode for our game. So what we can do is we can set that in the project settings. So if we go to edit and then project settings, and then over here in maps and modes, you guys can see that, right? Maps and modes, we can see here that our default game mode is first person game mode. I want to change this to Fire Escape game mode. And also, one of the cool things is we could set our default maps as well. So editor startup map is the map that's going to be picked when I open the project in Unreal Engine. So I'm going to actually just set that to level 1, and then that way every time we open this project, it just is going to open this level that we're currently working on. Whatever level makes sense to you. A lot of times, like in my games, I like to have like a sandbox level where I'm just like testing things to see if they work, and I will usually set that as this. Just so that way when I'm opening the game when I'm opening my project for the first time, this is just what's going to open. And then you can also set the default game map. So when the game is launched, what level is going to be opened. Usually for this one, you're going to want to pick like the main menu or the very first thing that the player should see when they load the game. We don't have that yet. We are going to set it up by the end of this week. So we'll leave it there for now. And then you can also set some other things. Split screen settings, things like that. Game instance, we'll talk about this in a future week. I can't remember which one it is. But yeah, this is where you get set up that. So now our Fire Escape game mode is set as the default game mode for this project, which means any level that we load, if there isn't an override, this will be the one that's loaded. And we can check this. We can kind of demonstrate this by here on our begin play in our Fire Escape game mode. We can drag off this. Let's just do a print string just to show. We can say get game mode and drag that in. And we can see that we will get the name of the game mode that we currently are when we load this up. And we will see it printed Fire Escape game mode. So did you guys see that? Let me see. Yeah, you can see it. Cool. So this is just to show that one, this is the game mode that we're using because it ran this begin play when we loaded the level. There isn't an override here, so it's going to use the default one. And then also we used get game mode, and we passed the display name in to print, so we now know that this is working. So one of the things that I want to do is I want to set up like a win condition for this game, and the win condition for this game will be when all the fires are put out in the level. So what I want to do is I'm going to use a get all actors of class, and I want to find my fire, BP fire, and what this node will do is it will actually find all of the fires that are in my level and get this little thing, which if we hover over it, says it's an array, and we haven't learned about arrays yet, which is a perfect segue into our next lesson, which is, drum roll, arrays and loops. So yeah, it's almost like I planned that. Trying to be the best instructor I can. Hi, my friend. How are you? I'm doing well. I hope you're doing well as well. We're doing a Game Dev Bootcamp live stream. So if you're new to game dev, if you're new to Unreal Engine, it's a great place to learn a little bit about it. So we're in week 2 right now. Last week we did week 1. Yeah. Yeah, you are right. So the question is, I think if you're watching on YouTube, you can see it. If you're watching on Twitch, you can't. How can I learn Unreal Engine better? I want to learn it better, and a lot of videos don't show everything. That's the whole point of this stream. The whole point of this stream is to learn Unreal Engine. So we started last week. You can go back and watch that recording. This is week 2 of an 8-week course. And we're starting with the very, very basics. If you've never used Unreal Engine before, you've never done game dev before, this is going to start from 0. So I recommend you go back and watch the first week. But this week we're building on a project that we made in the week 1 called Fire Escape. So arrays, what is an array? Oh man. All right. In this lesson, we're going to define an array. We're going to explain common loop types and their functionality. We're going to describe nested loops, and we'll demonstrate a loop implementation. Spoiler, we're going to use a loop to get track of all of our fires. All right, so what is an array? An array is used to store multiple values of a variable type. If you remember, a variable, we learned this in week 1, is a type of container. It can hold information. A variable, at the very least, needs to have a variable type in Unreal Engine and a name. An array, at the very least, needs to have a variable type, and we keep track of elements in the array. So each thing that we're storing in there is stored by an index. You'll often hear index. You'll look when we're in Unreal Engine. A lot of times it's gonna, like one of the nodes, it's gonna, when we use an array node, when we use like anything that's like getting information from an array or passing information into an array, we're gonna be using an index, which is keeping track of what position in the array. So if you think of it like a list, what position is it in the array? Is it position 2, 5, 100, things like that. Some common array actions in Unreal Engine are we can add something to an array, we can remove something from an array, we can clear an array, so we start from scratch. We can find an item in an array, so if we have an array of like 100 different fruits, we can look for one that's called orange. We can get a copy or a reference to that, so we can look for orange and then say, all right, I want to get a copy of orange, and I can use that for other things. So, common, when we are dealing with arrays, a lot of times you're going to be dealing with loops as well. A loop is basically like it sounds, it's going to loop through each of those. So if I had a list of 100 items of fruits, I don't even know if I could think of 100 fruits, if I'm being honest. And someone said, hey, what position is orange in? I would need to start at the top, programmatically speaking, and like start looking through the list, right? Start looking through the list. And then when I get to one that says orange, I'd be like, hey, orange is this one. So we would use a loop for that. So there's 3 basic types of loops. I'm using Unreal Engine, but I still understand Bootcamp very good. Yeah, definitely I recommend my course. I know I'm a little bit biased, but I've had really, really good feedback on my old course. So far, I've had good feedback on this course. So I think this is a really good place to start if you're having struggle. And I also have some issues, personal issues with the way that I learn. And a lot of times when people explain things in a certain way, it makes no sense to me. It's like they're speaking a different language. So I've tried as well as I could to break things down in a way that's easy to understand and that you can kind of grasp it. And I do also have a Discord that you could join if you want to ask me questions if you get stuck. There's a handy QR code above my head. I'm getting used to this, sorry. You can scan that, join the Discord. You could ask me questions on there. So their first type is a while loop. The input is a Boolean, so you're going to have an input of true or false. And as long as the Boolean says true, it's going to keep looping. It's just going to loop, loop, loop. So it's going to keep doing whatever comes after that while, as long as that remains true. A warning about while loops, I rarely use them because it's very easy if you don't know what you're doing to create an infinite loop, which will crash your game. So I usually just steer away from them unless I really know what I'm doing. For loops, the inputs are a starting integer and an ending integer, and it's going to run the code in the loop and increment until the integer gets to the last index. So if you want to do something 10 times, you would set the first integer to 1 and the last integer to 10, and whatever happens after this, it's going to do it 10 times. Yeah. Yeah, this I am doing the course live, but the recordings are also available on my YouTube, so you can watch them later if you get stuck. If you need a little bit more time, you can pause it, rewind, things like that. So if you tend to need a couple times to learn something, I recommend the recordings, but you can still hang out with us while we're doing this live. Yeah. All right, let's keep moving. A for each loop. So it takes the input is an array. What did we have? We had an array, right? And then it loops through all the items in that array. When we talk about nested loops, so you can put a loop inside of a loop inside of a loop. You could do this as much as you need to. And the way this would work is if we are, I don't think you can see my mouse. Yeah. If we start with the first loop, it'll start with the first element of that array or that loop, and then it will run the second loop. So in this case, we would start with loop 1, element 1 or index 1, go to loop 2, index 2, or index 1, go to loop 3, and then we would go through all the indexes of that, go back to loop 2, index 2, loop 3, all the elements of that, loop 2, index 3, loop 3, all the elements of that, and then once that gets done, we go back to the first one. So it's a way to compile on this. A good way to think about a nested loop is think about a deck of cards, right? You have 4 suits, and you have each suit has ace through king. So if you were trying to make an array of cards, you would maybe have one loop that has like an input of the 4 suits: spades, hearts, diamonds, clubs. And then for each of those, you would do add a card ace, add a card 2, and you would have an array of all of those. So that's like a good way to think of it. If you were trying to build a deck of cards, you could use a nested loop with suits being the first loop and the card types being the second loop, and you could use that to build a deck of cards. So yeah, also game dev is huge. There's so much to learn. Even on Unreal Engine, there's so much to learn. You're not gonna, I've been doing this 5 years and I probably know like maybe 40% of everything you could possibly do in Unreal Engine. There's just too much to learn. You can't do everything. So all right, so let's create an array of fires in our game mode. Let's go back here to our game, switch this view back. All right, so what are we doing here? We want to make an array of fires, and look, we have this output as an array. So what we can actually do is we can drag off of this and we can promote it to a variable. And now we see that we have this new variable called outActors. It's of type BP fire, which is convenient because we want it to be. And the variable type we notice has this like grid thing. And if we drop down, we could see here that the single is all the variables we've been using so far. There's an array, there's a set and a map. We won't worry about those, but right now we know about how to set a single variable. We can also set a variable as an array of variables. I'm just gonna change the name of this to be called fires array. So right when we begin playing, we're going to get all of the fires in our level, and we're gonna set that to a variable so we can keep track of all the fires. And one thing that we can do really quick is we can pull off here and we can say print. I'm gonna use an append node. So one cool thing about strings is I can call append, and I can have multiple string inputs and it will like put them together. So I could say like total fires, and off of this here, I could drag off and say length, and there we go. So this length node will give me how many things are in my fires array, and I can press play, and we can see we printed total fires 3. I don't know if you could actually see that, but I could see it, and it said 3. Let's go back to our level. Let's create another fire by holding Alt, and if we drag this, we'll create a duplicate of that. And now when I press play, it'll say total fires 4. So this is just showing that right off the bat, when we start our game up, we're getting all the actors, we're setting it to a variable, and then we're getting the length of that array, and we're printing total fires is 4. One of the things that I want to do though is I want to keep track of when a fire has been put out, and I want to remove it from this array, and then I want to check again to see how many fires are left, and that will be the finishing of this. That will be an indication of when the level is complete. We're gonna do this in steps over the course of this week. But for right now, that's kind of what we need. And I'm looking over here because I want to see what we're doing next. All right. So let's actually do that. What I want to do, and we're going to build upon this. So I'm going to do something like kind of a lazy way, and then we'll fix it after we learn a little bit more this week. Close that up. I'm going to create a custom event. And I'm going to call this check fires remaining. Check fires remaining. All right. And when this is called, what I want to do is get a reference to my fires array. And I want to get the length. And remember, this is going to return how many fires are in that array. And I want to see, is this greater than 0? Let's do less than 0. Less than or equal to 0. So I want the true pin to be the firing off of this. So when we call check fires remaining, we're going to get this fires array. We're going to check the length of it. If the length is less than or equal to 0, I don't think an array can have a negative element, but hey, why not just put an extra level of check in there, right? What could it hurt? Then we want to do something, so I'm going to say print, and I'm just going to, for now, print all fires are out. So this essentially will be our like win condition at some point. I'll use a print string just as like a placeholder. And then we need to call this when a fire is extinguished. So again, this is going to be kind of the lazy way to do it for now. So here we have this destroy actor. Remember, anything we put after this is not going to be called because the actor will be destroyed and then we can't call anything. I am going to say get game mode. And I'm going to cast to our fire escape game mode. And then I want to call check. I want to get the fires array. Actually, let's do this on the game mode. Let's be consistent. Let's create a new function called extinguish fire. Extinguish fire. Sure. And we want to have an input variable of our fire. And the reason is we want to pass in the fire that we're extinguishing. So here we can call extinguish fire, right? And we can pass in a reference to self. And then we'll connect this destroy actor. So when we pass in a reference to ourself, we want to get our fires array. And we want to say remove item. Yes. And that will remove this item from the array. So remember, I said in that lesson we can remove an item from an array. This will do that. All right, here's a question. It's better for me to work on coding of the game and what happens in the game, and after I finish this, we'll work on the environment of the game. It's a little bit of both. It's a little bit of both. Technically, if you're working on like a big studio, those would be like two different jobs. But as solo dev, we got to do everything. So I recommend my personal preference. This is not to say what's best. My personal preference is iterative game development. As a solo developer, you often don't have teams where you can like delegate things to. So what I say is build a little bit, make sure it works, build a little bit, make sure it works, build a little bit, make sure it works. I will say like polish or like the final details, like making sure everything looks super beautiful, usually is going to be the last step. Because if I spend 10 hours like making a gorgeous level and I'm like, this level is sweet, and then I realize something's broken and it doesn't work, now I have to redo that whole level and I've wasted 10 hours of my life. So functionality first, and then make it look pretty. But usually you want to like iterate, right? You want to start with like, if I'm making a statue out of a piece of marble, I'm not gonna like make sure that the nose looks perfect before moving on to like the mouth. I'm probably gonna like take off some big chunks, get like a general shape of a head, and then start like taking off smaller and smaller and smaller and smaller chunks. So it's just about iterative. Yeah. But it should always work before it's pretty. That's the best way I can say it. All right, so when we call extinguish fire, we're going to remove whatever fire we pass in from this fires array. And we've called that here. And then we want to, in here, we want to call check remaining fire, or check fires remaining. This is on our game mode. So now what this is gonna do, it's gonna remove that fire, and then we'll go to check fires remaining. We're gonna see if the length is 0, and if it is, all fires are out. And if it's not, we can do this. I listen to this is like this playlist is like it's like royalty free, so I don't have to pay anyone royalties for using their music on a 4-hour stream. I think that would get expensive. But every time I get to this song, I'm just like, all right, I think it's time to change the song. But it's like one long thing, so it's hard for me to just like skip a song. So I don't know, it's like so cheesy to me. But anyway, that's not important to game dev, right? Fires array. So if we don't have any fires, we're gonna print all fires are out. If we do have any fires, it's gonna print total fires. So let's play this, show that it works. We're gonna pick up our gun. We're gonna shoot this fire. We're gonna put it out, and it said total fires 3, total fires 2. There's another one over here. Total fires 1. And now when I put this one out, it should say all fires are out, and it does. So we have a win condition. We can now win our game. What do we want? We want a lose condition too. So depending on your game, you can do a few different things. We definitely like set up that the fires can do damage, so that's one losing condition. But another lose condition is like, let's put a timer, right? Let's make sure that players can do this within a certain amount of time. And to do that, we're gonna need to learn about how to set a timer. But guess what? That's the next thing we're gonna learn. I know, magic. It's like I planned this. It's like I spent hours of my life planning for this stream, so you all would have a wonderful viewing experience. Last week was a little rough in Florence. All right, let's do this. Let's learn about timers. So in this lesson, we're going to describe the purpose of timers. We're going to describe the advantages of using a timer versus other things, hint, hint, the tick node. And then we're going to demonstrate how to implement a timer, and we're going to use this to create a level timer so that we can see when we've run out of time for our level. So what is the purpose of a timer? You may have seen other tutorials that use the tick event to keep track of time. There's nothing technically wrong with this. You may have seen other tutorials that use a delay node to like set a timer. There's nothing technically wrong with this, but in almost every case, I'm going to use a timer. I do use delay nodes every now and then. Sometimes you have to use a delay node. I've just run into situations where it's like, all right, I'm just gonna use a delay. There's nothing better for this specific purpose. But in most cases, a timer is gonna be better. If you look in the Unreal Engine source code, technically a delay node is a type of timer set. So when you use delay, technically you're also using a timer. The advantage of using a timer, though, is it gives you a lot more control. So timers schedule actions to be performed after a delay. So we can see here, the inputs are time, so how much time is going to pass in that delay. What event or function we want to call after that. So you can see there's two different types: set timer by event, set timer by function name, and we can pass in like what do we want to run when the timer expires. And then we can also set up a looping behavior, which we are going to do for another part of this lesson, for this course. You can set up to loop over and over and over again until you tell it to stop looping. So let's, no, that's not what we're going to do. We're going to create, yeah, we can do that too. Let's first start by creating our lose condition though, of time. So here on our Fire Escape game mode, I want to set another variable, and I'm going to call this, it's going to be an integer. I'm going to call it level timer. All right. And we want to set this to have like a starting variable. Just for demonstration purposes, I'm going to set it to 10, so we're not like doing like super long levels every time. Matter of fact, we can probably even set it to 5. I also want to remove, there's a print string on my gun that's a little bit distracting. It's just not really helping. And it's clogging up my print strings. All right, so what were we doing? We have our level timer now. We have it set to 5 seconds. So what we want to do is we want to have this ticking down over time, preferably every second. So you could like try to do this another way, but I think the easiest way is to set up a new function called deplete level timer. And all we're going to do is get our level timer minus to get a decrement. So this is going to take that, we're going to remove 1 from it and then set that as the new value. And then I want to do a branch. Is this less than or equal to 0? And this would be our lose condition. And you lose, or you're out of time. And if it's not true, we'll do nothing, right? So we're gonna remove 1. When it gets to 0, we'll call you're out of time. All right, so this is just a function though. So how do we like make this do it every second? Well, right here off of our begin play, we also don't need this. Right off here, off our begin play, we can do set timer by function name. And we see we have this node, and we can pass in a function name. So we can call deplete level timer, and we can set it to do 1 second. And because we want this to continue happening, we can set it to looping. Now I will show you that this will work. So it's gonna start with, let's print. No, we're gonna wait 5 seconds. 5, 4, 3, 2, 1. At some point we will get, you're out of time. But then look, it's just gonna keep printing, right? So it's printing it now every second. We also need to, like, you can clear a timer, which is what we need to do. So here in our deplete level timer function, we can call clear timer by function name. And again, we need to pass in deplete level timer. Just be warned, this is case sensitive, so if you're not exactly the same, you are going to get a bug. As in, it won't work. Same with this one. If this is not exactly the same as the function name, it won't work. So, too many times I've been like trying to track down a bug, and then I realized it was just a typo. All right, so now when we deplete level timer, we're going to get it's going to do it only once. One of the things we could also do is we could print here. Let's do an append node. Let's call time remaining. We'll get this. So time remaining 4, 3, 2, 1, 0. You're out of time, and it only prints once because we cleared that timer. So that is how timers work. Now, one of the things though is like using these. Goodness, where is my? There we go. Using all these like print strings is getting kind of annoying. It's kind of hard to watch. It's not really cool. Also, these print strings only work like in the editor. These don't work like in a built game. So it would be good if we could have a way to like constantly show the player some of this information. So we didn't just have to do everything with print strings. Let's do a save all. So what we can do for that is we can use, wow, so good so far. Thank you, I appreciate that. I'm telling you, I tried really hard to make this not lame. Like I really did. We can learn about widgets and the UI setup. So this is how we can create things that give the player information. So in this lesson, we're going to explain the purpose of widgets, and then I'm going to demonstrate creating a widget that we could use to keep track of all the information, like how much water does our gun have left, how much health does our player have left, how many fires are remaining, how much time do we have left. All of these things can be created as a UI element for the player, so we can have like a constant view of these things. So we can use the widgets for this. So the purpose of a widget is it allows the creation of UI elements using the Unreal Motion Graphics UMG. I don't actually think I've heard anyone ever actually refer to it as UMG, but it is like what the system is called. We could do a lot of things with widgets. We can show text, we can show images, we can have a progress bar, we can have sliders. There's just like a lot of stuff we could do. It shares a lot of similarities with CSS or like any other, like if you've ever done like WPF projects in C#, where you're having to create like UI elements similar to that. I'm trying to think of if I've ever used any other ones. But basically you set like elements that give the player information or that the player can interact with, like even buttons, and then you program on the functionality of each of those, like what will be done. Widgets have a separate blueprint system. It looks very similar, but it is like it's its own thing because you need to be able to like set information to the player. And widgets, like you know, any other coding type thing, it can be like contain other widgets. So you can have like widgets within your widgets within your widgets, which is actually typically the way I like to do things. And that way, if you're changing like your HUD for your player, you don't have to like change the whole HUD. You can just change like one section of it, and then that will like report up to the HUD. So let's create a HUD. Let's play something for our player to interact with. All right, so to create a widget, it's pretty easy. I usually like to create a new folder called UI in my projects, and that way I can keep all the UI stuff in here. And then we can create our first widget. So I'll go to right click, and under user interface, there's a widget blueprint. We'll select user. You can see that there's all these different types of things. I'm just going to select user widget. The standard prefix for these is either W I've seen for widget or WBP for widget blueprint. I've seen some other people use other weird things, but these are like, I think, agreed upon like the standards. And then we'll call this HUD because we want this to be like everything that the player sees. So just to show like this is the that when I open this up, you have two tabs over here, the designer, which is going to show like the design of the widget, and then you have the graph, which looks like a blueprint that we've seen so far. Notice it's like a little bit different the way things are set up. You can move these things around if you want. But instead of begin play, we have this thing called event construct. You still have a tick, and you have a pre-construct, which is like things that are happening before the widget is created. So this one is called both by the game and the editor. this one is called after the slate is constructed. So I'm just going to use construct for this, and just to show, yeah. So here's what we'll do. We just want this one. This is like very similar to begin play. In the designer, this is the tab where you're actually going to be designing. So I usually like to start with canvas for my HUD because it takes up the whole screen. And we can see here that on our hierarchy, this looks similar to like the outliner or the components on another blueprint. So the canvas is the top level portion of it, and it is going to take up the whole player screen. I have a fill screen. You can change like some of these other things. You can change like a screen size to see how it looks on different things. And then we can change the name over here to, I'll just call this canvas. And then the details, we have some different things. Like if you're setting up this to be like played with a controller, you can set like how does it navigate, things like that. Before playing the game. Yeah, thank you. I think that was in reference to something I said a bit ago, but thank you. So let's set up a few things for our player to be able to see. We could see here in common, we have some like basic things. Let's put a text at the top. And when we drag it in here, we can see now it's like part of this UI, and there's this little thing that looks like a sun. This is where is the anchoring point. And we have some preset anchors. We can set this to like top left, middle, top right, directly in the middle. You can also have something like just scale to the size of the screen. So let's set this one anchored to the top middle. And now we can see like this is the anchor point for that. And we can set the position here. We can also like drag things around in our widget. We can set the size, so we can make it bigger, smaller, things like that. You can also size to context, which just automatically changes the size of this. We can also set the alignment, so X and Y alignment. So for instance, this is if we like set X position to 0, you notice it's pretty much like in alignment with this now. If we set it to 0.5, it's going to be set like at the midpoint, and if we set it to 1, it's going to be set to the right. We want this to be right in the middle, so I'm going to set it to 0.5, and then same with the Y. We can set this to like 50, and then if we change the Y alignment, notice it gets like closer to the top because now we're like, this is the point that we're aligning to. So I want to set this like this, and this is a text, so we can change what the text is here. I want this to be the time. Or no, let's do the fires remaining. And just for now, I'm going to have this say 0. And let's compile this. And I just want to show that we can actually like have this shown on the screen. I'm going to do it in my game mode. You could do this really anywhere. I think technically the player controller is the right place to put it, but I'm just going to put it here for now. So here, right after this, nope, we want to do it on my event graph. So we got our fires, we start the timer, and then I want to create widget. And this is allows us to like add a widget to the game. I'm going to use my HUD, and then this just creates it, but then we need to like say what do we want to do with it. Typically it's going to be add to viewport. This isn't always what we want to do. Sometimes we want to do other things, but for this purpose I'm going to add to viewport. So essentially what we're doing now is we are creating our HUD widget, and then we're going to add it to the player's viewport. And when I press play now, we'll see that at the top we have a fires remaining that says 0. But we actually want that to tell us the number of fires remaining. So we need to like pass that information in, right? Now, there are a lot of ways to do this. I'm going to do it the easiest way first. And as we learn more, I'll show you how to clean this up and make it a little bit more robust. But just so you know, like, this isn't necessarily like the right way to do it. It's the easiest way. The stakes are pretty low at this point, so it doesn't matter that much. But yeah. Just to show also, we can do some other things. We can set the color of this. So let's, like, because they're fires, let's make it like orange, like an orangish color. It's a little too yellow. Yeah, that looks good. We can change the font. So if you want to add a font, you could do that. It has some built in here. We'll leave it as Roboto. We could change the size of it. So we can make it like a little bit bigger. Let's go with 32. We can also like change how spaced out the letters are. So it gives you like quite a bit of control over this. One thing I also like to do for like these UI elements that are just text-based is I like to use this outline and just put a little black outline around it, just because now like you'll see it kind of stands out a little bit better. So it's a little bit easier to read, especially like if it was in these white clouds and it was white, it might be hard to read. So that's what I usually do. All right, and now for the, we want this to actually tell us how many fires are remaining, right? So let's, with this selected, we can see here this context next to it. There's this thing that says bind. We can see quite a few of these actually have bind. So under the text, let's bind it to something, and we'll say create binding. And this is going to tell us what does that text say. So, and we notice this is text, which is a type of string. We can actually make it a string by typing string, or we can pass a string in and then it will make it into text. But yeah. But what we want to do is we want to have this tell us how many fires are remaining. So remember we did that append node. We can do fires remaining. And then we can pass in an integer. But what is this integer? We need to get it like from our game mode, right? Because we're storing the number of fires on our game mode. So the easiest way to do this is here on our construct, we can say fire escape game mode. We can say get game mode. And because we're casting, we don't necessarily want to do this in this function. Just so you know, like these bound functions call every frame. That can be like very bad for performance, especially if you're using it for a lot of things. So then if I'm casting on top of that, it's not really great for performance. What I like to do is get a reference to my game mode and promote it to a variable, and I just call it game mode. And then I can use this game mode to get my fires array, get the length, and then pass that in. And now what this will do is it's going to bind whatever text is here to that element of our UI. So we're going to get the length of our fires array, which is the fires remaining, and we're going to append a string, say fires remaining, with that element of our array. So we can see now as we put out fires, the fires remaining will go down to 2, and then 1, and then 0, and bam, all the fires are out. So that's just like a very basic. Let's add a few more things to this HUD. Let's next show that we can add a progress bar. So I'll take this progress bar, I'm gonna drag it in here. I wanna put this one in the bottom right. I'm gonna anchor it to the bottom right. I'm going to set the alignment to 1 and 1, and then I'm gonna anchor it to -100, -100. So that'll be anchored to the bottom corner, like slightly offset from the corner. and I want to make this like 200 wide. It's pretty good. And with these progress bars, we'll see that there's like a percentage that we can fill up and remove. So you can set the way that it fills, right to left, left to right. This percent is like a scale of 0 to 1, so we can use a float. Fill from center even, that's interesting. Bottom to top. So that could be cool for like we're gonna use this one to keep track of how much water's left in our gun. So let's use bottom to top actually, that's kind of fun. Let's change the size to 60 and 100. Yeah, it looks like a little water tank now that we're depleting, right? We can also, with these progress bars, we can change the fill color. So we'll leave this one as white, as blue, but we can change it to something else. Let's do like a light kind of watery blue. And we can also change the background image. So right now it's just like this grayish one. We can make it like a little bit darker and maybe like not fully, like a little bit transparent. So we'll use like 0.6 transparency. And now we'll have like a little bar when we press play. You can see that little bar in the bottom. I think that's a pretty good size for that. But we need to set this to a percentage, right? So again, we can see there's like this bind thing here. We can bind that to a variable. So bind, create binding. And what I actually want to do is I want to, we can go to our gun, what is it, this one? Yeah, maximum water, current water. So we need to, this one's gonna be a little tricky because of the way this game is set up. I can't even remember how I did this. Let's just go for it. I want to get player character. Yeah, this is annoying. Again, this is we're doing this kind of like a backwards way because we don't understand all the principles to do this the right way yet. Player character. Move to variable player. All right. Get percent. So like here, what do we got to do? We got to get that component. Get component. Get component by class. This is the weapon component. We probably also want to check if this is valid. Just because if it's not, we're going to get a bunch of errors. Get current water, get max water. Oh, now look at this. So I think this is the first time we've encountered this in this course, but these are both integers and we need a float. If we divide this, we can't get a fraction. So this is either always going to be 0 or 1. So what we want to do first is change these to floats. So we can say to float. That will change our integers to floats. And then we can divide this and get a percentage. And again, not the most performative. We're just trying to show how it works. So essentially what we're going to do is we're going to get the weapon component on the player. I think I also want another is valid check here. Oop, what did I just have a feeling this is going to throw some errors if I don't do this. We're actually going to clean this up by the end of the week. So this is just to get this working. So we're going to get our player. We're going to get the weapon component on the player. We're going to get the current water and the maximum water. We're going to divide current by maximum. It'll give us a percentage of the water that's left, and then we'll return that. So now we will see that as we shoot our gun, the water is slowly depleting from that. Let's make it a little bit bigger. I don't like how small that is. Let's go 75 and 200. That looks good. So now we can see it's like slowly depleting, right? One of the things we can also see, we got errors. What is this? Oh. This is the barrel. I'm just gonna do this. This will prevent those errors. It's because we were shooting the barrel. All right, that'll make that go away. All right. Let's see here. What do we need to do? I think after this one, it'll be time for a break. It's been a little over an hour. Need some water. All right. So now we have a HUD element that shows our water remaining. We can actually call this something. We can change the name of this. I'll call this bar water. And then I'm gonna hold Control D, or over here we have to do it. So with this selected over here, I can select Control D. I can make a duplicate. I can anchor this one to this way. And this one I'm going to make the health, so let's make it green so it's clear that it's different. And this one I want to bind, create another binding. On our player, what did we do? We got this health component. So let's grab our health, let's grab our player. Let's get health, health component. Oh. What is this? Player, character. Not have a health component. Does. Current health. Again, we would need to make these two floats. All right. Now that will have our health. So if I walk into the fire, notice now I have half health, and if I go in there again, and then the player's health is depleted. So now we have some HUD elements to keep track of how many fires are remaining, how much health we have, and how much water we have. One of the things I want to do though is fire, I think like should hurt you over time, and water, I don't like this like having a click. So I'm going to actually implement a couple new things. The first one is on my fire. When we interact with the fire, this begin overlap on our collision, instead of having it just call apply damage one time, because we know about timers now, I'm actually going to set timer by function name, and I'm going to take this applied damage, and I'm going to collapse it to a function. I'm going to call this fire damage. And this function name I will call, let's do this. And I want to, the damaged actor, I want to pass in as a variable, like that. And let's call this fire damage. I'm going to do it like every 0.2 seconds, so it's like 5 times a second. And we need to like this won't actually work. All right, let's think about this. I've done this before. I know it works. Let's this other actor, which is the actor that overlaps, let's promote it to variable. Call this overlap actor. And then in here, we'll damage this guy. And the only thing, like now this is gonna kill the player really quick. So let's change this to like 5 damage. We could see that when we overlap with the fire now, our health is gonna start to deplete. Oh. 5 damage, fire damage, looping. Got it. So our health will start to deplete, but when we step out of the fire, it doesn't stop. We need to clear the function. So again, with our collision, let's with our collision selected, let's scroll down. We get on component end overlap. And here we can set this overlap actor to null. Nope, let's not do that. Let's not do that yet. Let's clear function. Clear function. Clear timer. Clear timer by function name. So we set the timer here. We also need to clear it. Fire damage. And then we will set this to null. Because otherwise, if this ticks, if this function calls while this is null, we'll get an error. So when we end the collision, we'll clear the function, we'll clear the timer. And then we're gonna clear out that actor. So let's see what happens when we do this now. We can go into the fire, we start to do damage, and then when we leave it, we stop taking damage. We'll go back in, stop taking damage. I think that's still a little too slow. Let's set this to, I want there to be like a, if I were to walk through a fire like that, it's gonna hurt. let's set the damage to 10. 5 I think is fine. Let's even set it to 1. And then this timer we can set to like 0.01. So like if you're in a fire for 1 whole second, you're dead, right? Oh man, that's like a lot. you gotta like dive through that fire or you're dead. Let's see if we can even make it through the fire. Okay, you could technically walk through 1 fire and not die. All right, so that's fun. Now we can take damage, which should be a losing condition that we can set up. Like here, we still haven't done that yet. We could set that up by the end of the week if we have time. So that would be 1 lose condition. We also have the time is running out. Time is running out. Complete timer. You're out of time. So we could set up that losing condition. And then we'll also set up the winning condition by the end of the week. Here, all fires are out. But for now, we have... Oh, let's set up one more thing. When we shoot this gun... I don't want this. I think that just makes like the gun have like kick to it, right? Let's see if that looks good. All right, we're gonna try something. I didn't do this in the demo, so like before I start these weeks, I also demo everything to make sure it works and I'm not giving bad information. Let's get rid of this. Let's collapse this into a function that's called. What is this doing? Get bullet spawn location. That'll be a pure function. I'm just trying to clean up some of this because essentially what I'm going to do is when the player pulls the trigger, I want to set a timer that we start to like just a stream of water instead of like. So I'm going to take all of this. I'm going to collapse it to a function called fire or start firing, right? And now we should see that that still works. But I don't want to do, I want to set a timer, right? So set timer, a function name, and we'll call start firing. I want it to be 10 per second, and it's going to be looping. Let's see how that works. We also need to clear it when we let go of the trigger. Oh yeah, look at that. I almost want it to be faster than that. Let's do 0.05. That's nuts. All right. That looks fine. So now, is it this one? Triggered. Trigger's been canceled. Let go of a key. So let's try this one. Clear timer. I can never remember which one it is, if it's canceled or completed. Start firing. My blueprint's easier to use than C++. I personally hate C++. I don't mind coding. I don't mind like script-based coding. I just don't like C++. So I actually find that I can make games very quickly using blueprints. I can iterate things like very fast. I've been using blueprints for like 5 years now. Technically, I've been coding longer than that, But as soon as I found blueprints, it was just like clicks for me. Like the way it flows, just it's like it makes sense to my brain. But I don't mind. Like I've used Unity before. That's all. It's all script-based coding in C#. I'm learning Godot right now using GD script, which is similar to Python. That's all script-based coding. I don't mind that. I just don't like C. I just don't like C++. I really hate it. But that's a good question. It really comes down to each person. Let's see if this works. Nope. It must be the other one. Nope, it's not that one either. Is it this one? Is this what I want? Maybe it's in my shoot input. There we go. Yeah, this we're gonna learn about this week, but this shoot thing, it has a trigger on it that makes it like a press once type thing. We needed to disable that. So now we have this that we can, when we call started, we'll set timer by function name to be a looping function on start firing. When we complete or release the button, then we'll clear that timer. So now we have just like a gun that can shoot like a stream of water. It is hard to keep organized if you are if you don't know the tricks. So I like to collapse a lot of stuff to functions just to keep things like clean. One of the benefits of doing that is like where was it? What were we just doing? Yeah, I think it was here. Like even this, like starting to look, so we could actually like take these two nodes, collapse to a function called set fires array. That one has to stay here, I think. So that's a lot cleaner. But yeah, it just comes down to personal preference. I don't think there's anything wrong with coding in C++. Like one of the beauties of Unreal Engine is like using both. But you know, again, it comes down to like you can't do it all. So you got to find something that works for you and do that. All right, so what do? We set up quite a bit. Let's just take a moment to review because I think this is like the halfway point for the week. Almost halfway. We're not doing good on time. I'm gonna run out of time. That's fine. Maybe I'll just keep pressing on. Get some coffee. So yeah, we kind of did a lot, but basically we set up this HUD. This is our health. This is the water. The barrel's still gonna replenish the water. The player character. What else? Oh, we set the fire to do like periodic damage here by entering and leaving the collision. And we also used a timer to set up some auto fire on our shoot event. So we call this start firing and then we clear it when we let go. So now we have like the startings of a game. I think these, I think maybe these projectiles do a little bit, it's like a little bit too fast to put out the fires. Let's put this down to 10. Yeah, like 4 to 5 fires per. I don't want it to be that you can just like not have to refill the water. Yeah, that's fun. Oop, now I need some water. Refill my water. Let's go put out this last fire. Cool. All right. Yeah, anything can be made a function. It is exactly. You got to keep it clean. It's just like coding in script-based coding, though. If you just have a function that's like 1,000 lines of code, that's probably not like that. Probably could be like cleaned up a little bit. There's a guy that I've seen a few of his videos. Like I don't agree with everything he says, but he says like. No function should ever go like more than 2 or 3 lines deep. I can't remember if it's 2 or 3. But like, if your function is going like 3 levels deep, you probably could like work some of that out. But I've seen really bad blueprints and I've seen really bad script-based coding. It really is just like you gotta be like have some discipline. All right. So we're starting to get a game loop going here. By the end of this week, the hope is that we finish that game loop. We're going to learn about a little bit more involved stuff next. I'm just going to take a quick 5 minutes just to get up and move around, get some fresh water. So hopefully you'll hang out, and I'll be back in like 5 minutes. All right. Did some stretching, got a fresh glass of water. We're ready to get back into this. All right, the next thing I want to talk about is interfaces, and I'll explain what these are in a second, but I want to give you kind of a scenario. And maybe you've played games in the past where it's like when you need to interact with something in the world, it'll give you like an interact interface, or like a way to interact with that object, right? Now, in game dev, oftentimes you need the ability to like pass information to another actor. You want the ability to like have the player interact with something in the world. For instance, if I go back to my game, you know, we've been setting up like all these various things, like when I interact with the fire, when I interact with this water barrel, when I interact with this gun, like. And each of these things has like its own functionality and we're handling it differently. It'd be good if we could have like one common way that the player interacts with things, and a way that like each of these could handle their own code when the player interacts with them. And for this, an interface is typically like the perfect thing. So in this lesson, we're going to explain interfaces. We'll talk about some common uses for interfaces. And then I'm going to create an interact interface for our player, or at least we're gonna get started. What do we do? Yeah. We'll get started on creating this interact interface. So, what is the purpose of an interface? An interface allows multiple classes to implement a common set of functions. And this is especially useful when classes are unrelated but have a similar implementation. So a good example is like a USB. This is typically the one I use because I think it's something that most of us use in our day-to-day lives. My phone has a USB and my car has a USB, and I can connect my car to my phone, and then both those objects have a way of communicating with each other. I can charge my phone, I can pass data back and forth. I can also take my phone and plug that USB into the wall, and then I can charge my phone that way, and that has a common functionality in the charging function. I take my phone and I can plug it into my computer through a USB, and now my phone can communicate with my computer, and all this is being handled by the USB. The USB is like a standard interface that a lot of different objects have, that allows the objects to pass data back and forth. So we can use systems like this in programming to create like common functionality between classes. So these are implemented in blueprints as a blueprint interface. You can also use them in C++, which we'll do later on in the course, much later in the course. But in blueprints, they're implemented as a blueprint interface. And a couple examples: anything that the player would need to interact with can have an interactable interface, in which case like the player could interact with that object, and then the object could have its own code. So like a good example would be you may need to interact with a door to open that door. You may need to interact with like a light switch to turn on and off the light switch. You may need to interact with an object in the world to pick it up. But all of these could have a common interface called interactable that allows the player to check that individual object to see what it can do when you interact with it. But the player is just interacting with any object in the world that has the interface, and then the object is handling its own functionality. Another example would be you could have a fire interface on a weapon, and that way each weapon could have its own functionality. So the player is only concerned with like pressing the fire button, and then you could have a pistol that fires one round at a time. You could have a machine gun that fires a stream of bullets as long as the player is holding down that button, or you could have a shotgun that fires a burst of you know, a spray of bullets all at once. And you could use an interface with this so that the player just needs to know, like, this is a gun and I can pull the trigger and fire, and then the gun fires itself essentially. So these are just a couple examples of interfaces. So what we're going to do now, and this is going to take a couple lessons, but we're going to start in this lesson by creating our interact interface, and I'll just show you a little bit about that. So let's change our screen again. And here in my blueprints folder, I usually like to keep all my interfaces in their own folder. So I'm going to create a folder called interfaces. And then in here, I'm going to right click, and I think it's under blueprint. You can see that there is a blueprint interface. If we hover over this, it says it's a collection of one or more functions, name only, with no implementation, that can be added to other blueprints. So the function is just like the name of the function, and then each actor has its own implementation of what that function does. So let's create this. The standard prefix for this is BPI for blueprint interface, and I'm gonna call this interactable. And now, like, if we open this up, you can see, like, it does have this graph in the middle, but there's no implementation here. Over here on the right, we have just a list of functions. So I can actually change the name of this to interact. And then we can set a few different things. We can set an input, we can set outputs of this function, those types of things. So this is all we're gonna do in this interactable interface. Like, we can actually close it right now. Let's create a couple new objects. I'm gonna create them over here because these are just gonna be like some test objects just to show that how this works. I'll probably delete them actually. So let's create an actor. I'm going to call this one BP destroy actor. I'm going to drag this in, and just to show what this looks like, let's add a sphere to it. And I'm going to make this sphere green. All right. There we can see our green sphere. That's the interactor. That's the actor that we can interact with, and we can destroy it. We can also create another one, and let's call this one DP float actor. And let's add a sphere to this one. Let's make this one, let's look for like a bluish color. There we go. Oh, we need to add that one too. All right, let's make a third one. This one we probably will save because this is what I actually want to do. BP door. And for this one, I'm going to add a cube, and I'm going to make this cube kind of skinny, like 0.2, 1.1, 2. Let's take this door. I'll move this fire inside. I'm gonna put it like right over here so it's like a hinge kinda. And then on my door, I'm just gonna move this cube up and over. So how big does that need to be? 150? There we go. Now that fire is trapped behind a door. So now I won't be able to put out that fire because I can't shoot through the door, right? So I want to be able to open that door. But we're just going to show how this interact interface works, and then we're going to delete those other ones. So here on my destroy actor, what I want to do is under class settings, we are going to, over here, we see implemented interfaces. We can drop this down and say interactable. And now we have this over here. It says we have an interface, and this says interact. And if we right click on this, we can say implement event. And this is the destroy actor. So we can call destroy actor. On our float actor, let's implement this as well. So we can implement interactable, and then we can implement event, and let's do a set timer, function name. Let's create a new function called float. And let's get root, set world location. If you are following along, I probably should have said this in the beginning. You don't need to follow this. I'm just trying to show how it works. Get world. We are going to make the door, so you can leave that, but you don't need to follow this part. All right. And we'll leave the door for now because I want to do that one last. So now we have our destroy actor and our float actor. Let's go to our, let's close some of this stuff out. We don't need that, we don't need that, we don't need that. Player character. All right. Actually, I do want to open the HUD because I want to do one thing. On my HUD, I'm going to put a text element. I'm going to put it right in the middle. If you hold Alt and press the 7 on your numpad, you'll get this like it looks like a period, but it's actually not a period. It's like a bullet point. Like if you were to like make a bullet point on your, and then I'm going to make it have an outline of 1. And now we have like this dot in the center of our screen so we can see where we're looking. And that'll give us an indication of where we're looking. So I think we actually, all right. I'm losing track of where I think I would get tired around 2 hours. All right, let's think for a second. What are we trying to do here? All right, let's just do this for now. Oh man. We're gonna come back to this. Oh man. All the people are gonna, all 4 of you are gonna start leaving now. All right. The point that I want to show in this, because I'll go to the next lesson. Like we're supposed to be building upon this, and I kind of like started getting into it. But the point being, like each of these actors that we made, right? Destroy actor, float actor, and then BP door, which if we add it to this, and then we can, I'm just gonna put a print string here for now, open door. We'll do this in the next lesson, or 2 lessons from now. Yeah. So each of these has this interactable event called interact that we made on our interactable blueprint interface. So we just made this function called interact. We implemented that interface into each of these actors. And now when we call that, each of these can have its own functionality. So this one, this one will destroy itself when we interact with it. This one will start floating. We set up this function to have it float up in the air. And this one is going to open the door. We're going to do this in another lesson. But for right now, all you need to understand about an interface is it allows us to set up functionality that's like has a common interface for different actors so that we can call a function and then that actor can handle its own functionality. And we're going to use this to create an interact system. So, yeah. And the benefit of this really is that we can have we don't have classes that are like dependent upon each other. Like one of the things we did here is like, we go to our fire. Like on this fire, when we put the fire out, we're getting our game mode and we're casting to fire escape game mode. And then on that game mode, we call extinguish fire. But like if we were to change the game mode, this fire would now not work because like it's like now it's coupled to that game mode, right? So if you make any change to the game mode, if we want to have like a different set of rules, now we have to reprogram this. So one of the things you're always trying to do in programming is like make code that is like can be changed easily without having to change like everything, right? So interfaces are one way we could do that. There's another thing that we can do that's called an event dispatcher. And we'll talk a little bit about those. And then we're actually going to like pretty much the rest of the week. Let me look at my lesson plan. Yeah, probably for a bit, we're going to be implementing ways that we can make this code like more scalable, right? So let's talk a little bit about event dispatchers. All right, should have taken a longer break. All right, so this is lesson 6. We're like a little bit more than halfway there, which is good because we're about halfway through the stream time, although the rest of the week won't take as long. So we'll have some time to clean up and then hopefully didn't confuse people too much. All right, so what is an event dispatcher? We'll talk about the purpose of that, and then we'll implement an event dispatcher in some way into this. So the purpose of an event dispatcher is it allows a blueprint to dispatch an event or to by calling that event, and then other classes can listen for that event and handle their own functionality when they hear that, which they could bind, which is called binding to it. So the dispatcher calls the event, and then you have listeners that bind to it, and they can trigger their own event when the call is received. So it's a one-way communication. The dispatching actor just sends the information out there, and it actually has no idea if anyone heard it. So if you were to like think of like a place that has an intercom system, if you're like in a grocery store or like a school or something, and you hear someone over the intercom like John to aisle 3, right? If you're not John and you don't work there, you're probably just gonna ignore that, right? If you are John, you're gonna listen and you're gonna be like, oh, I just got called to aisle 3, and you're probably going to go walk to aisle 3 and do whatever you need to do when you get there, right? If John is not in the store, then John did not hear that message. So the message was sent out and John was not there to hear it. So nothing happens. And the person who called the message doesn't know if John heard the message. So they just called it and then they're going to wait. And if nothing happens, then I guess they get their answer. But in programming, like you wouldn't get that. You would just get nothing. You can handle this. It's a little bit more complex, but you can handle this with a callback, which would be like when an event is dispatched, you can have the receiving actor dispatch its own event that says like, I heard you, or like, I acknowledge that you sent me this. That would be more like a walkie-talkie, right? You click the walkie-talkie. Hey, John, you there? You're going to wait. You don't know if John heard or not. John's probably going to click his walkie-talkie and say, yeah, I heard you, right? So that would be a callback. But in both those cases, they don't actually know if the other person heard each other. Now, this is very useful when multiple classes need to be aware of an event, and they each need to fire their own independent functions. So like game over is one where I usually use a dispatcher. Typically the game mode in my games, I have a lot of dispatchers that like dispatch things along the way. And you can do this to like create like something happens, and then I'm going to broadcast a message to everything in the world that something has changed. And the things that need to be aware of that can handle their functionality, and the things that don't need to be aware of it, just ignore it. Just like shoppers in a store that don't work there and aren't named John, probably you're just gonna like ignore that message because it doesn't pertain to them. So this can be done with something called an event dispatcher. So we're gonna create an event dispatcher, and we're gonna call when all the fires are out. And now I feel like we're getting back on track. So hopefully too many people didn't leave when I came back from my break and I forgot completely what I was doing. All right. So how do we create an event dispatcher? We're going to go to our Firescape game mode. And like I said, I want to check that all fires are... I have this event here for check fires remaining. And then I had this print string of all fires are out. But I want to replace this with something that will broadcast a message to the world that all the fires are out. And so down here, you see this says event dispatchers, and we can click plus, and we can create a new dispatcher. I'm going to call this one all fires out. And then personally, I like to add dispatcher on the end of these, just so that it's very clear that this is a dispatcher. If I had a function called all fires out and then had a dispatcher that's called all fires out, that could be confusing. So I usually just add dispatcher on the end to remind me that dispatchers are happening. And this song is back. Let's change this music up. Alright, this one's pretty chill. That song, man. Just can't. Alright. Oh, I gotta go to this one. Alright. I don't actually... Yeah, you can see it. So it's down here. Dispatcher's out. So now, what I could do is I could drag this in, and it gives me a list of things here. So I can call, bind, unbind all, create an event, which I've never actually done. That's interesting. Didn't know that was a possibility. But let's just call it, right? We want to call it. So what this is going to do is it's going to call out into the world that the fires are out. And then anything that needs to be aware that the fires are out can be listening for this, and it can handle its own functionality. So one thing that I definitely want is that let's do this fire, BP fire. let's go to our HUD, right? Let's do this. Let's do it on our HUD first. This one's pretty simple. I'm going to create another widget. So user interface widget, user widget. I'm going to call this WBP level complete. And in here, I'm just going to create a text. I'll change this fill size to desired. I'm going to change the text to just say level complete. Let's change it to be like 60. We'll add some outline to it. And then I want to add this to my HUD. So remember I said you could add a widget to a widget. So I can actually search for level complete. And we can see that there's a widget here called level complete, and we can just add that straight in there. For this, let's size to content, so it's going to be the right size. I'm going to set the X to 0.5 and the Y to 1, and I'm going to anchor it to the center, minus 100. Now the level is not complete though, right? So we don't want to see that. We don't want to see that until the level is complete. So what we can actually do is set the visibility to hidden. And now it's not showing, right? What we can then do is on our event graph, here where we get that game mode, we can drag off of this game mode that after we set it, and we can that all fires out. If we type that, there's a thing that says bind event to all fires out dispatcher. And if we click that, let's put this in our execution. You notice that there's this red pin down at the bottom. We could drag off there, create a custom event, and we can just call this what we want. I'm going to call it level complete. And when this event is called, I want to get my level complete, and I'm going to set visibility to visible. So now when the last fire goes out, what is happening? Oh, I can't put that fire out because that stupid door. Man. All right, I need to make a note to myself for next time. All right. That fire's out. Oh, I'm running out of water. Gotta go fill up my water. Should have done the event dispatcher first and then the interfaces. All right, level complete. So the last fire was out and the level is complete. Now, let's do some other things, right? One is when the level's done, I don't want to be able to shoot my gun anymore, right? So I can go to player character. Nope, it's that gun. So I can go to player character. Let's do that here. We don't need that. Let's do get game mode. Fire escape game mode. All fires out. And we can bind an event here. And we'll call this custom event. All fires out. All right. So now when all fires is out, my player character will do something, and what I want to do is disable. So get player controller, disable input. Is this going to work? Let's see. Now the input is disabled. I can't move the player anymore, but the gun is still firing, right? So we can also do this on the gun. Game mode. And now the gun stops shooting. So we can see here that like what we did is we created a dispatcher which sent out a message to the world, and then each of these actors is listening for that event, and when they hear it, they each do their own thing. We could also demonstrate this. Yeah, let's get, we got it back on track. Let's not go off track again. So hopefully that explains a little bit about how dispatchers work. Again, we can call a dispatcher on the actor that has the dispatcher. So in this case, when all the fires went out, we called all fires out dispatcher, and then each of these actors listened for it, and so on begin play, we bound to that event, and then we hear it, when we're listening for it and we hear it, we call our own individual functionality. This one disabled the player input, so we can no longer move around. The HUD showed the level complete HUD element, and then our weapon cleared the timer to stop firing. So each of these did its own thing, but the dispatching actor, being the game mode, just like didn't care. It doesn't even know that anybody heard it. It just sends the message out into the world, and then each of those things can each do their own functionality. We could also do the same thing, for the most part, when the timer runs out. So if we go to our deplete level timer, and we have this "you're out of time," we can create another event dispatcher for that called out of time dispatcher. And we can call this here. And now, when we run out of time, we can call this timeout dispatcher. We can do the same thing. We can create a UI element called WVP out of time. And this one would just, again, have a text element. Go back to our HUD. We can add out of time. Set it to desired, 0.51, anchor it to the center. Set the visibility to hidden. And then here we can make a little bit more room. Get our game mode out of time. Now when we run out of time, which I think is still set to like 5 seconds, you're out of time. And we can do all the same stuff, disable the input, make sure the player can't shoot. So yeah, that's a little bit about how dispatchers work. Again, the dispatching actor, in this case being the game mode, doesn't care what's happening. It's just calling it, and then anything that needs to listen to it, in this case the widget, we had also set up for the other components, is going to listen. When it hears its message, it's going to do its own functionality. So that's dispatchers. Now, when I came back from the break, we got off the rails a little bit. It's my fault. I was so prepared for like the first few lessons. I got like high fives. People were like cheering for me. I went on a little break, came back, kind of forgot what I was doing, but I think we pulled it back in. What we want to do is we want to like finish that interact system that we created, that we started on. But in order to do that, we got to do a few more things. The first thing is we need to like actually set up some way to interact. In this case, I'm going to use the E key, or we could use the F key, I think is gaining popularity now. We need some way to like interact with objects. So I want to be able to like create locked doors you got to open. You even create like a system where you got to like go unlock it somewhere and then come back to it. But in order to do that, we need to create a new input, and then we will round out creating that interact system. And then there's a few more things we want to do by the end of this week, but I think those will be a little bit faster. But let's get things back on track here. All right. I'm just changing screens real quick. So we're going to learn next about creating player input. This is going to be an overview, a really brief overview of the enhanced input system. So let's get into lesson 7 of this week. So in this lesson, we're going to explain the enhanced input system. This is a new system that was released in Unreal Engine 5.1 or 5.2, I can't remember, that changes the way that we handle input. In the beginning, I hated it. I've come to appreciate it, I will say. We're also going to create a new mapping for our input action, which is going to be for our interact. We're going to demonstrate mapping that, and then we're going to create an input action event on our player. So I'm playing on a PC right now, but there are, different input types. There's mouse and keyboard, common for PC games. There's controllers, common for console games. There's touch screens, common for like phone games or tablet games, or even if you play on a monitor that has a touch screen. There's also motion inputs, which are gaining popularity with VR. Your iPhone or Android has a gyroscope in it, so if you ever played a game where you gotta like tilt the phone, we had this, that was a big one. Nintendo Switch, I think maybe even PS5 has it now, I can't remember. But like having some way to interact with like the motion of the player. These are all different input types. They're all supported with Unreal Engine. And we want to be able to create the ability for our player to interact with our game using one of these input types. So we can use the enhanced input system. This took the place of the older input system that was part of Unreal Engine. It's still there, but you get like a note that says it's deprecated. So this is a system for mapping inputs to an event. So we can pass an input into the engine and the response is an event. So we've already been doing this with our mouse and keyboard moving around our player. We've been doing this with shooting our gun, and we can create more of these as well. Like if we wanted the ability to, I think there's also one for jump, but in this case we want the ability to like interact with things, so we're going to create an input. So this can be done through blueprints. It can also be done through C++. We're going to be using blueprints for this lesson. And as part of the enhanced input system are the input action and the input mapping context. The input action being things like move, look, shoot, jump. It's an action. Like anything that's an action is going to be an input action. And then input mapping is what maps the input, maps the physical input to the event, to the input action. Now, one good thing about the IMC, input mapping context, this is one of the huge benefits of the new enhanced input system, is you can actually add or remove inputs at runtime. So if we go into we'll go into our weapon, and we'll see it's actually adding an input to be able to fire the weapon. And if we don't have a weapon, that input does not exist. And if we click the mouse, like nothing happens. So that's one of the benefits of it. So let's start by creating an input action. So all of the ones that come with Unreal Engine, they're in the first person folder, and then there's this input folder. We can see that there's two IMCs here, one for the default, one for IMC weapons, which is how we get access to the ability to fire the weapon. And then we can see here we have these input actions. So we can create a new input action if you right click and then go to input action. Let's create one called interact, IA interact. And then the next is mapping that input action. So again, if we go back to our IMC default and we open this up, we can see this mappings drop down, and here's the mappings that we already have. We have the ability to jump, move, and look. If we drop these down, we can see the look is mapped to my mouse XY, which allows me to look using the mouse. If we had a gamepad, it would also be mapped to the right thumbstick. IA move is mapped to WSD. It's also mapped to the arrow keys. And if we were using a game controller, it would also be mapped to the left thumbstick. Jumping is mapped to spacebar on the keyboard. And if we're using a joypad, grab this one, it would also be mapped to A on an Xbox. I think this is X on a PlayStation controller. So this is how we map the input action that we just made to an input from the player. So to do that, we can just click mappings to add a new one. We hit this plus sign, and now we have this new empty one down here. We can do interact, and if we drop that down, we could see it's allowing us to choose an input that we want. There's a handy shortcut key that I almost always use. And if you click on this little keyboard and then press a button, it will map it to that button automatically. So I can press F instead, E, I'll leave it on E. I like E for interact. I think F is gaining traction, but I guess maybe, I don't know, maybe I'm old school. Is that the old school way to do it, is E? So now this interact event is mapped to E. So we can now do the last part, just creating a new event for it. We can see here we have this event here for looking, moving, jumping, Let's create a new one down here so we can type interact, and we should get this IA interact. So input enhanced action events, IA underscore interact, and we can see a little arrow for the interact event, and there it is. If we drop this down, we can see these other options that we were messing with when we were trying to figure out how to shoot our gun. So if I drag off here, off this started pin, print, I'm just going to print I interacted. And now when I press E, I'm printing I interacted 1,000,000 times. And so now our E key is mapped to that event. Now, remember we said we could add and remove things. So like here, if we go to our blueprints folder, we have that rifle pickup that was built into this starter project. We could see here that like when we overlap with it, so this sphere, right? When we overlap with this actor, it's doing a few things. We haven't really talked through this, I don't think, in last week, but we could talk through it now that we like kind of understand what these do. So we're casting whatever overlaps with this actor, we're casting it to player character. Because the first thing we want to do is see like, is this actually a player? And if it is, we're gonna set it as this reference character. So we're setting it as the value of reference character. Then we set this Boolean character as weapon to false, but then here it's get children components of our first person mesh, and it's checking to see what this loop is. Now we understand this for each loop too, right? So we can kind of break this down. So it's going through all of the child components of our first person character, all of these, and it's trying to look if any of them is a weapon component, and it set this as false up here, right? And if it is, if we find a weapon component, we're going to set this to true, which would give us an indication that the player has a weapon. This is not how I would do it, but sure. Whatever. It's fine, right? I think they're just trying to show you how to do stuff. Then down here, after this loop is completed, so this is like the body of the loop, right? And then off completed here, we're gonna check, does the player have a weapon? And if they do, then we're gonna do nothing, right? So all of this is just to see, does the character already have a weapon? If they don't, we're gonna add a BP weapon component, which is this up here. And then we'll destroy the pickup. Now this one, again, we're gonna get owner, make sure it's first person character. We're going to attach it to the character so it looks like they have a gun. And then look at this. We get the controller of our first person, we cast it to player controller to see like that this is actually a player. And then from that player controller, we get access to that character's enhanced input system. If that's valid, meaning they have an enhanced input, then we add a mapping context, which is weapons. And if we go to that one, it's got its own mapping of shoot, which is left mouse button or the right trigger, which is like the trigger, like you're firing a gun. So if we notice though on this one, that firing ability doesn't exist. We're adding it to the player, which is one of the beauties of the enhanced input system, which then gives us access to this shoot, and then we can do this stuff. So it's kind of like a weird way to do it. I think I have some appreciation for it. It's just not necessarily the way I would do it. Let's close this. Let's close this. Let's close this. Let's close this. Let's close a lot of this stuff. All right, got just some basics now. So now we've added the ability to interact in the world, and we kind of talked through how we added this enhanced input when we pick up the gun. So hopefully you have like kind of some understanding. Again, like the enhanced input system is very broad. There's so many things you can do with it. But for the purpose of this week, all we needed to do is to add the ability to interact, which we did. Which leads me to the next lesson, where now we are all the way back on the rails. All the way back on the rails. We're gonna finish our interact system. The problem was earlier, like I just started doing things I wasn't supposed to be doing at that point in time. And then once I realized it was too late, I was already confused. And yeah, so we're back on track. All right, let's keep going. So in this lesson, we're going to describe line trace by channel blueprint node. This is what we're going to be using to check if we're interacting with something. We're going to demonstrate implementation of a line trace on our player character. We're going to create an interact widget. So we're going to create another widget. And then we're going to finish our interact system. So we have some pieces. We're going to make sure everything works now. So it's a line trace by channel node. So what this does is, I mean, it's kind of self-explaining, but not really, not enough to like just say like, oh, I know what that does. So what it does is it has a few inputs. It has a starting point, which is a vector, so a point in space. It has an ending point, which is a vector, so an ending point in space. And it's going to draw a line between those 2 points. And then it has a trace channel, which can be visibility or camera. We'll look at what that means in a second. But essentially, it's going to draw this invisible line. And if that line hits anything, then we get an output. And it's going to return a Boolean of whether or not it hit something. And then it returns this struct. We'll learn about structs, but it basically, as we can see here, a struct is a type of variable that can hold multiple variables. Now, different than an array, which can hold multiple values of the same variable type, a struct is a variable type that can hold a bunch of different variables. You can actually have an array of structs, which we will do later on in the course. But just so you know right now, a struct is a collection of variables. And we can see these are all different types. So like this output hit is all of these things. It's all of this stuff is contained in this one output. So structs can be really useful. We'll use them again, but just for now, just understand it's just a bunch of variables all compacted into one variable container. And they don't need to be the same type, which is the benefit of it. Over, like an array is used for different things. An array can only hold one variable type though. So again, this is kind of like explaining what we're going to be doing. We're going to have our character is going to be sending out one of these invisible lines into the world. We're going to be looking at an endpoint, which is going to be some point ahead in space. When we turn the character, that line is now suddenly going to be interacting with something, and then we have access to all of this information from that actor. So let's implement the line trace onto our player. Here on my player character, I'm actually going to use the tick function, tick. And we haven't really talked about this yet. The tick function fires every frame by default. So if I were to do like print string, hello, and then hit play, it's just gonna keep printing hello, like forever. You probably, if you've watched other tutorials, you probably already know about this. Let's show a little bit better view here. just continually printing, right? So this is happening every frame of the game. You can change how often it fires in your class defaults tick interval. So we can make it fire like only every half a second if we wanted. And now you can see it's just like a little bit slower. It's still firing every half second, but it's definitely slower. If it's 0, it goes to the default, which is the frame. Yeah. Yeah. I don't know if Asaf is still here. Or did I miss something? I don't know. Anyway. So we're going to use this tick to create that line trace. So I'm going to drag off here. I'm going to type line trace by channel. And we need to set a starting and ending point for this line trace. So I want the line to always be like a point in space directly ahead of the character. And we had this, we set up our UI to have this little dot in the center. So I want that dot to be like an indicator of what we can interact with. And we can do this by getting our camera, because our camera is what's creating the view. And we can get a reference to that, and we can say get world location. And this will be the starting point of our line. If we look in our viewport, this would be like right there. That's going to be the starting point of this line. But we want to send it out into space. Right? We want to find like some point in space ahead of the player. So what we can actually do is say get forward vector, and this what this node does is it says like a vector in terms of like what this is returning is it's returning a vector, so a thing of 3 values, but it's like in the what is the forward direction. So you can almost think of this like as a rotation of whatever, like what direction is in front of the player. And we can take this world location and we can add some value to it using this forward vector to get the end location. And if we do a multiply node and add this in here, and then change this, what we're multiplying it by an integer, we can essentially set a length that the line is in the forward direction, ahead of the player, ahead of the camera, and that will give us an end location. So let's just set this to something like 500 to start. And one of the benefits, one of the things on this line trace is we can have a debug line. So we can say for duration. And when we press play now, we'll see that something's weird is happening. But if you look, it's actually like sending one of these little lines from the camera. So if I just stand here for a while and I like draw like a little circle with my camera, and then I go over here, you can see it like created a cone. So we can see like also there's a few different things, like it's giving us like a little red square when it hits something. We can see over here, we're hitting these spheres that we made. And sometimes the line turns green. So if we go like this, you can see that the line turned green on the other side, which means it's returning like it did hit something, and it hit this ball. So what we could actually do is, remember we said we can see this is true if there is a hit. We can also drag off of this out struct that we talked about, and every struct has the ability to break it, which means we can look at like all the things that are in there, and we can look at this is the reference to whatever actor is hit. So we can say let's do a branch, and if there's a blocking hit, we can print the name of the actor that we hit. So let's do that. Let's see what happens. So we can we're hitting this rifle, and we see it's printing BP rifle pickup. Now it's hitting the floor. We can go over here. It's hitting float actor. I don't know how well you can see that. And then here we're hitting destroy actor. If we go over here, it's hitting the door. It's hitting, oh, I'm gonna die. I am dead. Notice it's not hitting this because this doesn't have any blocking collision, because this is a blocking hit, right? If we change this to this pin, then it would, I believe. See BP door. No, it's still not blocking. But anyway, yeah, you get the point. You get the point. So what we can actually do now is, let's delete this and this, is we can take this actor and we can see implements, does object implement interface, and we can set this to the interactable interface and print, nope, branch. All right, so 1, are we hitting something? 2, does that thing that we hit have the interactable interface? And then we can print this. And now, if we notice, the gun is no longer printing. The floor doesn't print anymore, right? But if I go over here, now my destroy actor, I'm printing that. Float actor, I'm printing that. And door, I'm printing that. So we can see that we implemented the interface on these 3 different actors. See, I told you I was doing this for a point. Because this has that interact interface implemented, we can use that as a check to see if something actually has the interact interface. And then we can control whether we can interact with something based upon that. So what we can actually do is take this, and I want to promote it to a variable. I'm going to call this interacting actor. And I want to set this on this true pin. So if we hit something and it has the interface, then I want to set that to the interacting actor. One thing to be wary of is we also want to set it to null, meaning no input, if we're not interacting with something. I think we also want to do this. And I could show you a bug if we don't do this after we get a little bit further. But now, what we can do is, where is it? Here, is we can print only, so when we hit the interact key, which I bound to E, it's gonna print what is interacting. So if I press E, I'm pressing E, nothing's happening because there isn't an interacting actor. Well, I'm printing, but I'm printing nothing. If I go over here and I am interacting with something and I press E, now I start printing the name of that actor. Float actor. Door. Right? We're getting there. I hope you could see we're getting close. All right. So now we can call interact. And we can see here BPI interactable. Interact is the message. So now when we press the interact key, we will call the interact function which is going to call whatever, or the interact event, sorry, which is going to call whatever we have. So on destroy actor, this interact event is going to destroy it. When we call it on the float actor, it's going to set this timer to start floating. And on our door, it's going to call this, it's going to print open door, because we're going to program that. So let's go over here, let's call it, and it destroyed itself, so that worked. We're going to call it here, and it's did something wonky that I didn't want. What happened there? Interact, float. Was it too fast? Get world location. Float. Get world location Z. +1. Anyway, I don't know where it went, but it's doing something. Set. All right. Should I do this one instead? Oh, that's why. These two need to be passed in here. Look at that, it's starting to float. We can speed it up. Let's put this as 3. It's floating away. And that happened because we interacted with it. That one destroys itself, and the door will print open door. All right. We're back on track. We did it. We made an interact system. I want to show you what happens if we don't do this, though. So let's disconnect these pins. So now, if I interact with something, that is now set as the interacting actor. But if I stop interacting with it, it's still set as the interacting actor. So I can press E, and it will still destroy itself. So I'm interacting, I stop interacting, and I press E, and it's still going to start floating because, yeah, we never unset it. So that's why this needs to be here. And I think also the reason we need to do that other pin, I think this still does the same thing. Like if we get right on the edge of it, yeah, see, even though we're too far away. So we need to clear this out essentially when we're no longer interacting with something. We need both of these because, like, if it was like this, we would stop interacting with something. I guess that could work too. Let's see if this works. Or no, this one will, like, if I do this, it'll still print, see, open door, because I'm now interacting with something, but it's not interactable. So these both need to be connected. I thought so. All right, so that works. All right, we got this. So now we have an interact system in our game. One more thing that we could do is we could set something in our UI to tell us that we're interacting with something. So let's create another UI widget. We'll call this WBP interact widget. And in here, I actually want to use one I don't think we've used yet. It's called a vertical box. And we're going to put some text in here. So I'm going to make this one just say E. This is going to be pretty big. Now what a vertical box does is it allows me to like stack two elements on top of each other. So I can like create like basically like a column of things. There's also horizontal boxes, which will create like a row of things. And then you can have like mixtures of those. If you've ever done Flexbox in CSS, it's kind of like that. Like flex row, flex column. This E I want to be centered. And this text block I want to say to interact. In our HUD, I want to add that interact widget. Put that anchored to the center. Size to content 0.5 on the X, 1 on the Y. Minus 50. That looks good. E to interact, right? So that's a widget now that'll tell us, but we only want to show it when we're interacting with something. So let's set visibility to hidden. What do I want to do? I want to get a reference to that. So I think actually what I want to do I'm going to put this on my player character. Back here, play. But I want to set this as a variable called HUD. So now my player character is what's creating the HUD. Now down here I can get a reference to this HUD, get a reference to interact widget, set visibility, and now what this will do is if I am interacting with something, it's going to show it. And if I stop interacting with something, it's going to hide it. So let's see how that works. Interact. Interact. Let's give ourselves some more time. How is a guy supposed to finish in 5 seconds? I'm going to make it 60. So now we can see I'm interacting. I'm also, now that we have that working, I'm going to stop showing that debug. So we don't have those annoying red lines all over the place. And now see, we're interacting. We can interact with the door. We can interact with this ball. This one. We can set it to float. We can destroy it. And the last thing I want to do is on that BP door, I want to actually do this. So what's the next? don't actually know if I have anything in here about timelines. All right, I'm gonna go off script a little bit because I want this door to work like a real door. So I'm gonna go off script. This is not in the lesson plan for this week, but I think we have time. So we have like an hour left ish. We only really have like one thing to do and then some cleanup. So I want to create the ability for this door to open. So we can actually use what's called a timeline for this. So I'm going to say timeline, add timeline. This is going to be called open door timeline. All right. And there's a few ways to do this. This is just one way I've often done. So we can get this cube, which I'll just name this the door mesh. This is this cube for our door. Let's make our door like wood too. A nice wood door. All right, so we can get this door, right? And what we want to do is we want it to like rotate like it's on a hinge, right? So I could do this by changing the rotation of the hinge of the door, and if because of the way that we put this mesh on there, that it's like lined up down here with this origin point, if I rotate the whole actor, we can actually rotate the mesh as if it's on a hinge. We can also like demonstrate this like if you don't want to rotate the whole actor, if you want it to like keep a reference to where it is, what we can do is we can add an arrow component as an indicator of like where this is, and then we can attach the mesh to the arrow, and then we don't have to rotate the whole actor in the world. We can rotate just the arrow, and then anything that's on the arrow will rotate with it. So let's do that actually. Let's get rid of this. Let's rotate the arrow. And what we want to do is we want to set the rotation on the z-axis. So I'm going to say set relative rotation. Relative meaning like in relation to where it currently is. And then the way these timelines work is if we double click on it, we can open it up, and it has tracks. We can add different kinds of tracks, float, vector, event, things like that. We're gonna use a float, and we're gonna call this alpha. And up here is the length, so how long will this timeline take to complete? So a timeline is essentially like you want something to happen over time. So I want the door to take 2 seconds to open. And then this timeline is almost like a graph, right? So we can right click and we can say add a key. We can change the location of this key to 0, 0. And then we can add another key, which we can have at time of 2, which would be the end, and a value of 1, which would mean over the course of 2 seconds, this value of alpha is going to change in a linear fashion. We can right click on one of these and change the type of curve. So we can make it more like a curve. So it'll start slow and then accelerate and then slow down. You can change the angle of this. So if you wanted to like happen very quickly at first and then decelerate. So like for this, I would think of like a helicopter coming in for landing, it's gonna like come in much faster, and then as it gets closer to the ground, it's gonna slow down so it doesn't like smash into the ground all at once, right? I'm gonna leave it like this because actually I think this is pretty natural of how like a door would open. Like you gotta give it some oomph, but then you don't want it to like slam open, so you would want to like slow it back down over time, right? And now we have an output pin here called alpha, which correlates to this. So you can have multiple tracks actually if you want to do like multiple things with a timeline. And we can use this update pin, connect this here, and we can set the rotation to a node called lerp. So if we say lerp, linear interpolation is what it stands for. This is off script, so don't judge me too hard on the things I'm saying here. And we can have a starting point of 0, and we can have a ending point of 90, 0, 90, and we can use this alpha to change from 0, which this is relative rotation, so 0, 0, 0 relative is wherever it started, and it's going to move to 0, 0, 90 over the course of 2 seconds. And just to show how this works, I'm going to change this to play from start. So now when we interact with the door should look like it's opening. Look at that. It just keeps doing it though, right? So that's kind of like weird that we don't want that, right? So now if I interact with it again, I want it to close. So we could do that pretty easily by creating a branch here. And then from this branch, we want to promote this to a variable. I'm going to call it is door open. And if it is door closed. Let's call it is door closed. Is door closed. If it is closed, then we want to play from start. If it's not closed, we can actually just use reverse from end, and it will change the direction. But now we need to set this. Set is door closed. We don't want to always set it to true. We want to set it to the opposite of what it currently is. So we can get this, use the not Boolean to switch whatever it is. And now I believe you should have a door that very naturally opens and very naturally closes. If you interact with it like halfway through, it gets a little wonky. We can fix that by there is an easy way to fix this. Can't remember. I'm trying to think. You got to change something here because this is going to always go from 0 to 90 or from 90 to 0. So I think you have to like set. Anyway, it's fine. There's also another way we can do it by creating another branch here. This is the way I usually do it. Door promote to variable. Door is door moving. This way just like prevents it from happening. No, I think I got it backwards. Look at that, we got a door. I don't think I need that printing anymore either. Alright, so now we can put that door back in place now that we can interact with it. Our game won't be broken. Open the door, get to this fire. This fire. Last fire. Can we do it in time? We did it. All right. What else do we need to do? All right. So we now have an interact system. We showed that it works. We can interact with these. We showed that each of those could have its own functionality. We have a door. I'm actually going to delete these. This float actor we don't need either. If you were following along, I apologize. We just need the door. I just want the ability to like make some puzzles that are kind of fun. You gotta find some doors, open them up. Maybe there's some fires. So yeah, we're getting close to having a completed game loop. But one thing, like when we start this game, like if we put out the fires, right? Let's open this door, put out this fire, grab some water. Like there's like a few things that we gotta finish up still, right? Put out that fire, and the level's complete, right? But what happens next? Like that's the end of the game? No, that's like not a fun game. We would love to have like multiple levels in this game, right? We would love to have like that you launch the game and you don't just jump right into firefighting. It would be cool to have a main menu. All right, so let's talk about creating a main menu for our game. And so in this lesson, what we're going to do is we're going to create a main menu for our game. And then we're also going to demonstrate how to transition between levels. So we can start at the main menu, transition, we can pick from a list of levels at some point, pick the level we want, transition into that level, play that level. When the level is complete, it'll give us an option to go back to the main menu. So usually in a game, the main menu is going to be its own level. Now, this really can depend upon your game, but every game I've ever made, this is typically how you do it. And this way, the player just doesn't like launch into the game right off the bat. So the first part is we're going to create a main menu level. We're going to create a main menu widget that the player can interact with. And then we'll create a way to transition from that main menu into our level so we can play the level. And then at the end, we will want to go from that level back to the main menu or to like a level select screen or something like that. So let's start by creating a new level called main menu. So I'm going to go back to my top level, and in my levels, I'm going to create a new level. Oh, actually, let's not do that either. Let's not do that. here's what I actually want to do. I want to save all. So you can do that. You can create a new level that way. Or we can go to new level. And I'm going to create an empty level for my main menu because I just want it to be like a UI that the player can interact with. So I'm going to select create. I don't want anything in here except for just a blank level. And this will also allow the game to like load very quickly when they launch it. So we don't need anything in here. Your game may be different. Matter of fact, further on, we may make a more complex thing. And then I want to save this. Save current level as. I'm going to save it in my levels folder as main menu. So now that we're in our main menu, what do we want to happen? Well, if we press play, we're playing the game right now. We don't want that to happen. We want kind of nothing to happen, right? So what we actually want is to create a new game mode. So I'm actually gonna clean this up a little bit. I'm gonna create a player called game modes. I'm gonna put my fire escape game mode in there. Okay, fine. And then I want to create a new game mode called BP main menu game mode. Now, remember I said we can actually like override the game mode in any level. So now that we're in our main menu level, we can go over here to our world settings, game mode override, and we can set that to main menu game mode. And now when we press play, nothing happens. We have no UI, we have nothing, right? And then in this game mode, we can set up the functionality for our main menu. So we don't need these, we just need the event graph. So what do we want to happen when we begin play in this main menu game mode? Well, we probably want some UI. So let's create a main menu. We'll create a new user interface widget. Call this one main menu. I'm going to create a canvas because I want this to be on the whole screen. I'm going to create a text box that's going to tell us the name of our game. Let's put it right in the middle top, 0.5 x 0. I'm going to call this fire escape. Let's make it nice and big. And then in my main menu game mode, when we begin play, I can just create widget, main menu, add to viewport, and now when we press play, we have the name of our game. We next probably are going to want a way to start the game. So we can create a button here. Actually, I think I want to have a few buttons. So I'm going to use a vertical box. And I'm going to put this vertical box in the center of my level. 5. And then in this vertical box, I'm going to put a button, and this button I'm going to change to button underscore start. So that way I know that this is the starting button. And then on a button I can drag some text, and I can change the text to say start game. And now I have this button I can press to start my game, but nothing happens. So on your UI, When we have a button, if we scroll down, we can see that there's these events and we have an event clicked. So if we select this plus sign, it'll go to our event graph, and now we can see on clicked button underscore start. So what do we want to happen when we click this button? Well, eventually we're going to want to load in like whatever level we want, right? Or maybe we want to go to a level select menu. Just to keep it simple for now, because we only have one level, I'm going to open the first level. That's what I want to do. So I'm going to use a node called open level by name. And we can pass in the name of our first level, which was level 001. Level 001. And when I click that now, I'm in my game. So now I want to do a few different things. First off, you notice like if I click into the game, I lose my mouse. So we want to change that. So we can do that by saying get player controller, say set show mouse cursor, and click that on. And now when I click, I can still get access to my mouse. Oh, you can't see my mouse. Wait, why can't you see my mouse? Why can't you see my mouse? You're supposed to be able to see my mouse. Oh well, must be a Streamlabs thing. Anyway, so that works. You can also do set input to UI only, because in our main menu we're only going to be like interfacing with the with this menu, and we don't actually want to play the game. You could set this. The only thing is if you set that like that, then in your other game mode, off this begin play, get player controller. We want to do set show mouse cursor to off, and then set input to, I usually pick game and UI. There are some cases where I would do just game, but this is how I usually do it. So now when I start game, is it game? Input. Set input. Is this what I want? There we go. All right, so we want to do a few more things, but anyway, we now have the ability to go to the main menu. Now in this level complete, we want to have the ability to go back, right? Back to the main menu. All right. We're getting there. We're almost done with the week too, and it's gonna be like perfect timing. All right. So now, from that level complete, actually, I want to do like one more thing. All of this. What's this? All right. So like the interact widget, this little circle in the middle, all these health bars and everything. I want to. I want them all to be hidden when the level is complete as well. So here, out of time. Level complete. Let's do this. Give ourselves a little bit more room. So on level complete, let's create another set visibility and we'll set it to hide. And then we can actually just like grab all these and just plug all of them in. Bar water is not, that's bar health. Oh, this one's, what is that called? Text, interact. Yeah, if something doesn't show up here, it's because it needs to be set as a variable, and you can just click this is variable up here. So now when I put out all the fires, all of that stuff will go away. And then my level complete widget, we can just add a couple more things. So let's create a vertical box. X, vertical box. Let's create button. Let's create another vertical box within the vertical box to hold the buttons. What? All right. Here we go. Text. Restart level. There's also it's called a spacer. It doesn't hold anything, it's just like some space. Like, give me some space. Put one of those down here. And then we could copy and paste. The spacer I can just add like 20 to the Y. And then this button, I can have it say like main menu. All right, so now when we complete this level, let's put out these fires. Now we have a level complete. It's going to show us some options, but we need the ability to interact with those options. So we also want to, you could do that in the game mode. Set show mouse cursor. Set input to UI only. And then we can click these buttons now. But they don't do anything. So we got to do something about that, right? So let's go to here and actually let's name these buttons the correct thing so we know what they are. So this one is restart. And this one is main menu. Go to our graph. We can, with this selected, on clicked, main menu, let's say open level by name, main menu, it's gotta be all one word. And then this restart, we can say on clicked, restart. Now, we're gonna have multiple levels in this game at some point, so we want it to be able to restart the level that we're in. So we can actually use get current level name. And then we can do open level by name. Also, this is maybe I'm being a little bit of a but like, why is get current level name return a string and open level, like why is it not a name? Why is it not a name? Because now I gotta have this. All right, anyway, I'm done, no more. All right, so now we have button restart that'll get whatever level we're currently in and it's gonna open it. Or we can go back to the main menu by clicking the main menu button. So let's show that this all works real quick. And we are almost done with our first game loop. And therefore our first template, our first project template, which is pretty cool. That. All right, let's go a little bit slower this time. All right. Where's my mouse? There it is. Oh, you can't see it. So I can select restart level and it restarts the level, and I did hit main menu last time. All right, and if I select main menu, then I go back to the main menu. So that part works. So for the most part, we have a working game, for the most part. There are a few other things that we need to clean up though. So we're kind of like getting to the end of the stream. We've got like a little more than 30 minutes left. So really what I want to just do is like some project cleanup before we close out the stream. If people have been following along, I don't think anyone has, but if you are, you can ask some questions. But there are like a few things I know for sure we want to do. First of all, when we like are taking damage, which is around here somewhere, there we go. Let's do this. Take damage. Also, like so yeah, what I just did there is like you can highlight some things and press C to create a comment, and then I could say begin. These are just ways to like create notes to yourself about things. You can even like just highlight nothing and create a comment. Just create like a random node that's like, you should be aware of ... So like just notes to people. You can also click this little bubble and it creates like a bubble that even shows when you zoom out. So like for primary things, like things I'm gonna need a lot, I like to turn that on, like begin play. Damage seems to be one. This allows you to like keep things a little bit tidier in your project. I am notoriously bad at this. Like, if you look at some of my projects, they're just like this, or it's just like a bunch of stuff. But so let's do this. C tick. One good thing about doing that though is like I think it's I think they are like you can find them if you search for them. So like if I do this tick, you can see that there's a comment called tick, and it will send me to there. So like if I created a comment like this one's interact. Sometimes I'll do this to like leave a note to myself, like I will do a comment. No, what did I do? I commented a comment. And I'll write like to do, and then here are some things to work on. And then you can like create a list of things. And then if I search now for to do, I can find that. So like if I didn't remember where I put it, or if I wanted to see like, are there any things to do? I could just search for to do, and this, you can like leave a little list of things for yourself. Just like some little things to help you. But one thing I know for sure is like the player cannot die yet. So we probably need to do this, right? And again, like because our game mode is where we're handling level flow, I think I want to create an event called game over, right? And I want this to do some things, but I also want it to send a dispatcher out. Game over dispatcher. And I want to call this because now like when this deplete timer, we had this out of time dispatcher. Which we can also call game over. Here. And then that could handle its own things, right? So like this, for instance, the deplete level timer. We want that in both places, right? So we could just clear the timer here. And now when we run out of time, we just call game over. And that will call this game over dispatcher, which will also clear the timer. You could also you could have just a game over, like a general game over message. Like when we run out of time currently, what is it? It just says like out of time. Maybe you want two different conditions, like when the player dies in the fire, that something different happens than if they run out of time. Like maybe they can still complete the level, but they don't get the high score or something, you know? Things like that. So it gives you a lot more control, but I do need to have this player die. So let's delete this print string. Let's instead get game mode, fire escape. And we're gonna call game over. Now in game over, we're going to call this game over dispatcher, which let's just create another widget that's just a game over screen, right? And this is going to be a canvas because I actually want it to like block the player's view of the game. Right? So we can drag an image onto this canvas. We can set the anchor to the, like this one that she'll show it's taking up all 4 corners. And then we can make it full screen. We can make it black and like 0.7 opacity so the player can still see through it a little bit. And then we can add some text. Put this in the center. Let's make it all caps. Game over. Let's see if we can die now. I might be missing something. Game over. Oh yeah, first try. Oh man, that was crazy. It worked. That's all the player can see now. It's just game over. All right. This definitely is like me hitting a wall. All right, so now we can die. So in this game over, we probably want, what do we want? Probably just want a button. Let's make this a little bit bigger. 40. What is button? Main menu. Tell I'm getting tired. All right, this one will say restart. Level. I want all of this in a vertical box. All right, that's working. Let's got a bug. Got a late hour bug. How did I break it? That's weird. All right. I think we're good. I think this is good. I think this is good for the week. We did a lot. All right. I think the interact distance is a little too far. Do I plan to make my own game soon? I like making tutorials. The problem is that a lot of work goes into a game. Making a solo game is, there's a lot of things I don't enjoy doing. So like if I was to make a whole game, there's like a lot of things that I would prefer to have someone else do. So I'd want to outsource them, which means now I need a budget. And so, you know, I'm not in the path of releasing a game for myself anytime soon. I have released some games in the past. There's one of them on Steam. There's another one that I did, like a few Game Jam games I've done, one of which won an award. You can find that on my itch page. Yeah, I like making prototypes. I like prototyping games. I've had a few contracts in the past making games for people, which is a lot of fun because it's challenging to make someone else's idea a reality. I prefer that actually to making my own games. Not that I don't have, dreams of and aspirations of making some grand game, but to me it's a lot of fun to like work with a team, and just don't have the time or the budget for that at the moment. So, but all right, we got a few minutes left. I think we can just kind of like wrap up everything we did this week. So if I go back to this kind of overview thing that we made. So this was week 2 of an 8-week course. During this week, we covered what the game mode is, and we used that. We set up 2 different game modes, actually, one for while we're playing the game, one for while we're in a menu. We talked about arrays and loops, and how you could use those in your games. We used that to keep track of an array of how many fires were in the level that we load at the beginning of the level, so each level you can just kind of keep track of them. We talked about timers. We set various timers in our game. We set a level timer to keep track of how much time the player has left. We set a timer to do periodic damage to the player when they're standing in a fire. And then we used a timer to set up an automatically firing weapon that can start and stop when the player is pressing the left mouse button. We talked about widgets. We made a lot of widgets. Widgets are super boring content. I find like a lot of people like dip out when I start making widgets. Because this is the first time we're talking about widgets, I wanted to make them on the stream to show you how they work. In the future, I'll probably pre-make any widgets we're going to make, and that way we're not spending stream time creating widgets because it's boring, it takes up time. We're trying to pack a lot of content into each of these weeks. We talked about interfaces. We used an interface to set up an interaction system for our game. We talked about how we could use an interface to set up different functionality for each of the interacting actors that we set up. If you guys were watching the stream at that time, this is where the stream. I took a break. If you're going to watch the recording, I took a break. And when I came back, I kind of forgot what I was doing and got a little confused by myself. We got a little bit off the rails around lesson 5, but we pulled it back in. By the end of lesson 6, I think we had pulled it back in. We talked about dispatchers and how we can use an event dispatcher to send out a message into the world, and then any actor could be listening for that dispatcher and perform its own functionality when it hears the message. We talked about creating input. We looked at some basics of the enhanced input system, and we used that to complete our interact system by creating an interacting event so that we could press the E key and interact with objects in the world. We rounded out that whole interact system in week 8, and by this point I think we were back on the rails. In lesson 9, we set up a main menu and we talked about how to transition between levels using the open level by name node. And we use that to transition from the main menu to the level and then back to the main menu again. And we also use it to reload the level if the player completes the level and wants to try it again, or when the player gets game over, we can restart that level. And then we spent the last few minutes just kind of rounding everything out, trying to complete our game loop. So we accomplished all the tasks. We now have a working game loop where the player can win the game by getting all the fires out. The player can also lose the game either by standing in fire too long and dying, or by running out of time. So if you were following along and you want to spend some more time on this game, you could create some additional levels. You could continue building on the level that we created and kind of work it out so maybe it's a little bit more fun. We created a door that you could open and close, so you can create multiple rooms with doors, those types of things. You could also create a UI element that tells the player how much time they have left. So one thing currently is the player does not have any indication of how long they can play this game before they run out of time. So you can set that up if you want. There's a lot of things that we could continue to do on this game, but for the purpose of the course, really we just wanted to make a prototype. We wanted to show that we can get a working game loop going. If you were following along and you want to show me what you did, you can head to the Discord. There's a link there above my head. Head to the Discord, show what you worked on. If you're watching the recording, you can use that to ask questions, or if you were following along on the live stream and you want to head there and ask a question, maybe something we didn't get to in the live stream, or maybe something that wasn't quite clear, especially around lesson 5 and 6 where I got a little off the rails. But I communicate a lot with the group there. There's a lot of other people on there, so definitely check out the Discord if you haven't yet. This recording will be available, so if you missed a portion of it, you want to go back, you can go back and watch it. And as well, week 1 will be available, as is already available as a recording. So if you missed week 1, you can go back and watch that, watch week 2, and then you'll be caught up for week 3. In week 3, so we're pretty much, hey, how's it going? You caught me right at the end. So in week 3, we're going to be starting a new project called Alien Defense. This is going to be like a top-down, wave-based shooter. In week 3, we're going to focus a lot on object-oriented programming and what that means. We're going to continue this project in week 4, and that'll round out our second prototype. So if you want to come back on next Friday for week 3, here's the schedule. This is going to be from 10 a.m. to 2 p.m. or 10 to 1400 if you're outside the US or you're in the military. Keeping it real for Bootcamp style, you know. So on these days is where we're going to be streaming these. Again, if you can't make the stream, you can always watch the recordings later. But yeah, I hope you learned a lot this week. I hope you had fun on the stream with me. And yeah, I hope to see everyone next week for week 3, and we'll get started on our alien defense project. So yeah, check out the Discord, check out the other videos on my channel, and I will see you all next week.